All right, everyone. Chapter 7, which is lesson 7.1. We're going to start off with normal distribution. Please download that, and we'll go through this lesson together on probably 2 videos. We'll probably have to do here to fit it all in. Probably 2 roughly 5-minute videos each. The normal distribution. Very important, very famous concept in statistics. You'll see normal curve, or sometimes you'll see what's called the bell-shaped curve. And those of you who've taken psychology course with Mr. Klein, you're probably familiar with these terms. So the normal curve, or the normal distribution, or the bell-shaped curve, these are all synonyms for one another. It looks like this. It looks like a bell, obviously, where that starts out low and then rises up and then peaks in the middle and then comes back down again. And it's symmetric. My drawing is very off here, but it's a symmetric curve. Here's a better one. It peaks in the middle. It's symmetric. It changes curvature at the inflection points. It levels out at the tails, and it doesn't go below the x-axis. So here you have a curve that looks like a bell shape. So what this essentially means is that over any population, you have lots of the population members kind of all bunched up here in the middle, right? All roughly around average. That's what this mu is down here. That's the mean, right? That's the mean. So the average is right in the middle of the bell curve, right at the peak. So you're in any population, whatever you're measuring, whether it's IQ scores or SAT scores or height and weight, whatever it is, you're going to get most people kind of bunched up here in the average range. And then as you go further away from average, as you go this way, you get less and less people, which means the height of the bell curve shrinks. It gets smaller and smaller. And then when you get out here, or by the same token out here, you have very few of those people. Those are the outliers, right? So you'll notice all of these U minus sigma, U plus sigma, U plus 2 sigma, U plus 3 sigma. So let's talk about what all that's about. So let's go down... let's do an example here. IQ scores have a normal distribution. So in America, your average IQ is 100. It's the average IQ in the country of America. The standard deviation is 15. So you take an IQ test, you score 110 or so. You're basically above average, right? Now, when you draw your bell curve, what we're going to do is we're going to draw it in levels. So you always put the mean in the middle, right? That's the 100 right here, right? And then what you want to do is you want to draw 3 lines, and this is already done for us, representing 3 standard deviations. You want to draw 3 lines right and 3 lines left. So you want to add 3 standard deviations. So basically, if mu is 100 and sigma is 15, well, then we're going to add 15, which gives us 115 right here. Then we're going to add 15 again, which gives us 130. And then we're going to add 15 again, which gives us 145. And we're going to do the same thing backwards. We're going to subtract 15, subtract 15, subtract 15. So these are the 3 levels, right and left of the mean. And these are basically the 3 standard deviation levels. All right? So there is a law in statistics. And you'll notice all these percentages in here, right? There is a law in statistics. It's called the empirical rule or empirical law. Basically, this rule or this law governs what percentage of the population is contained at all these benchmarks. So basically, if you have a normal distribution, between 1 standard deviation left and 1 standard deviation right is going to be 68% of your population. So a little quick math, if you take 68% and you divide it in 2, you get 34. That's where these numbers come from, 34 and 34. So if I asked you what's the probability that someone scores between 100 and 115 on their IQ test? Well, it's 34%, right? Because 100 to 115 is this 34% right here, right? So that's the first percentage you need to memorize. Then as you go out another standard deviation, that's going to be 95%. Okay? So a little more quick math. If you took this 95 and subtracted 68 and then divided that by 2, that's going to give us your 13.5 and your 13.5 that you see here and here. And then finally, 3 standard deviations left and right is going to account for almost everything. It's going to be 99.7% of the population. So that, if you subtract 99.7 minus 95, you get 4.7, and then divide that by 2. You get 2.35, which is this and this. All right, and then finally the very, very farthest, the furthest reaches, like at the very outskirts of the bell curve, is 0.15% and 0.15%. Those are the extreme outliers. So these percentages never change. These are always the percentages for the normal curve. As you'll see, yeah, no, maybe it's a couple slides down. Scroll down to, yeah, this slide right here, number 6. This is the most important slide, and this is the most important concept of this whole lesson. Right here, again, it's called the empirical rule. You have 68% of the data values within 1 standard deviation. You have 95% of the values within 2 standard deviations. And then you have 99.7% of the data, which is almost everything, within 3 standard deviations. So it would be very wise to memorize all of these percentages in here, as well as down here, as well as that's 0.15% at the very outskirts. That one's not given, but you should know those as well. All right, I'm going to end this video now, and then we'll do an example.